In this video we're going to examine something called the greatest common factor. The greatest common factor of two or more whole numbers is the largest whole number that divides evenly into each of those numbers. So in order to find the greatest common factor, one of the things you're going to have to do is find the factors of various numbers. So in our first example, what we're going to do is use two numbers, and we'll use 18 and 27. So one thing that you could do is ask yourself, okay, what are all the factors of 18? By that I mean, what two numbers can I multiply together to get that product 18? So of course the first way to do it would be to multiply 1 times 18. I also know that 2 and 9 when multiplied together will give me 18, and 3 times 6 is 18. So right there I have all of the factors of 18. Then I'll go to 27. Factors of 27 are 1 and 27. And the other way to get those numbers is 3 times 9. So those are all of the factors of 27. So if I look at both of those sets of numbers, I'll notice that my largest factor that they have in common is 9. And that is one way to find the greatest common factor of two whole numbers. This way is okay, except that you really need to know your multiplication facts right off the bat. Hopefully that factor investigation sheet can help you with it as a reference, but there's a couple other ways that are just as effective, and we're going to talk about those in the coming slides. Another way to find greatest common factor is to use the prime factorization of numbers. So we're going to do that repeated division again. So I'll start with 18, and the first thing I'm going to do is try and divide it by the first prime number. So I'll write those back up at the top there as a guide. So say to myself, okay, 18 divided by 2, does 18 divide evenly by 2? Yes, it does. 18 divided by 2 gives me 9. So 9 is an odd number, so 2 won't divide evenly into that. But if I go to my next prime number, which is 3, I do know that 9 does divide evenly by 3. It gives me a quotient of 3. And 3 divided by 3 works, which gives me my 1 and done. Now I'm going to do the same thing with 27. And if I look at 27, again it ends in an odd number, so 2 is not going to work, so I'm going to go to 3. 27 divided by 3 gives me 9, and it's going to look a lot like the one to the left. 9 divided by 3 gives me 3. 3 divided by 3 is 1, so it's 1 and done. So now what I can do is have a look at the prime factors in each number. So if I look at 18, I'm going to write down the factors of 18 here. And so I have 18 is equal to 2 times 2, times 3 times 3. 2 times 3 times 3 is 18. Then I have 27. So here I have 3 times 3 times 3. So now if I look at those factors that are lined up down here, I can see that they do have some that are in common, and the ones that they do have in common are the 3's there and the 3's there. So if I take those and I multiply 3 times 3 together, the greatest common factor is 9. The final way that I can calculate greatest common factor is to go back to the Venn diagram. So if I take 18 and 27, I can split those into their prime factors again, so 2 times 3 times 3 from what I did on the last page, and over here 3 times 3 times 3 gives me those prime factors of each number. Now, what I can do is have a look at those numbers, and you can see that I have 3 times 3 there, and look over here I have a 3 times 3 there. So what I'm going to do now is move those factors that I have in common on each side into the middle. So 3 times 3 there, moving in, and 3 times 3 there. So all I need to do now is take those and multiply those together. So bring those down here. 3 times 3 gives me 9. So there's another way to find the greatest common factor of two sets of numbers. If you wanted to do that with 3 sets of numbers, you could do pretty much the exact same thing, just following similar steps. Hope this helps you out, and look forward to seeing you guys again real soon. Thanks, and bye-bye.